Hey, year 12s. So I turn my mic on there. I'm going to take up one of the future value examples. To start, when we talk about future value, we use a future value table. Here are your main three steps. So the first thing you're going to do is you're going to determine the time period and the rate of interest. You're going to use that information to find the intersection of the time period and the rate of interest through your intersection point, and then you're going to multiply the number in the intersection with the money contributed. So let's look at our first example here. I'm just going to scroll down a little bit. See if this writing moves with us. Oh, it does. Great. Okay. So we're going to use the future value table above to do this. So for A, we are investing $34,000 per year. Up at the top, the future value table is for $1. So it basically predicts the value, the future value of $1. I'm looking at investing it 6 times over 6 periods. So $1 6 times. So it could be over 6 months, $1 per month, or over years, which could be 6 years. But if that number on the side is for the number of periods that you're investing it for. So notice it's going up as you would expect by 1 each time because you're investing an additional dollar, and the additional decimal values represent the interest that's usually being earned. And then eventually as this gets higher, you're definitely going to start getting quite a little bit up there, and these values are not going to be as linear in the progression. But to get started, in A, we are investing at 3 years, so our amount of periods is 3 because it's compounded annually. The next thing we have to look at is the interest rate of 5% is being used, so that means we are using 5%. And now we have to find the intersection point. So we read across and down to find 3.1525, and we use that. So to find A, future value equals the intersection point value, so 3.1525 multiplied by the principal being invested each period, which is, wow, a lot of money, $34,000. I'm sorry, I just don't have a ton of room to work on this slide. I can only write on the picture, so I'm going to have to erase this once I got it done. 3.1525 times 34,000. And that is equal to, I got $107,185 would be the value for that one right there. So that's A. I'm going to have to erase it all. So I'm just going to assume in reality you're pausing the video if you're writing this down. But I'm going to erase this because I need room to work on B. So I'm just going to erase everything I've just kind of written out here. See if I can make my eraser a little bit bigger. Go. So for B, we're going to use the exact same methodology. So for B, it's the exact same idea. There we go. Perfect. Okay. So back to normal here. There we go. So for B, piece of information important. 5,000 is the amount we're going to be investing. So we're going to be multiplying. So that's going to be the money that's being contributed each time. Per half year for 2 years, compounded 6 monthly. So that means 2 times per year. So if we're investing it for 2 years and we're compounding it twice and we're investing every half year, that means our periods for this one is 4. Every half year for 2 years, it's going to be 2 times 4. The next thing we're going to do is we're going to take our 6%. So we have our 6% that we have here. And that 6% is compounded 6 monthly, but that's a per annum percentage. So that means, again, we have to divide by 2 to get to 3%. We now use that 3% above in our table. And what I do with in our table is I know that that's 3%, and we're able to find our intersection point. So our intersection point is 4.1836. So I take that intersection point, I'm just going to erase a little bit so I have a little bit of room down here. I take, so our future value will equal for B, and this is for B that I'm working on. Our future value will be $5,000 multiplied by the value at the intersection point, 0.1836. 1836. Sorry for that. 8 looks like 2 disconnected dots, but it's hard to draw with my finger on the screen. So that makes 5,000 multiplied by 4.1836, and that equals, I have no room down here at the bottom, so it equals $20,918. That's how you get the answer for B. I'll be making you another video on how to do the other example, so example 7. Okay, one more example there. In this one again, we're doing using future value tables. So for A is where I'm starting. What is the future value of an investment? The contribution that's going to be made is $300 per month that we are going to be regularly depositing for 3 months at 24% per annum per year, compounded monthly. So I'll kind of go over some of the details. So number one, our period is 3 months, or 3. So I'm going to do it monthly per month at 3 months. So we know that our period is going to be 3. Now, if I take a second and look at 24% and quickly look at the very top here, notice that 25% is nowhere up at the top for my percents. That should be a clue that we need to do some more math. Number 2, notice I underlined monthly before. So this is a per annum percentage. So that means you have to take 24% divided by 2 to get, oh sorry, not by 2, by 12, because there's 12 months in a year. And we need to take that and divide the 24% across 12. And we can all probably do that in our heads to get very, or much more usable 2%. So I'll make that look a little bit more like a percent. So there's 2%. There's our intersection point for the first question. So just like before, to find the future value for A, I'm trying to find places to write. So I'm going to write up here for A. A, the future value equals 3.060 multiplied by $300, which is our regular contribution. And on a calculator, sorry, I'm just getting my calculator going. Working in a dark room right now, so it's a little hard to see. Times 3.060 equals a total amount of money that it will be anticipated to be worth be $918. So A, done, no problem. B, let me erase a little bit. Let me just change the size of my eraser just so it's a little bit easier for me to erase some of this stuff, so I can clean things up. I'll leave the answer for A up there if you're still writing. So A, done. B, what is the future value of an investment of 15,000? So we'll be multiplying by that after. Per quarter for 1 year at 12% per annum compounded quarterly. So number one, an investment of $15,000 per quarter, and there are 4 quarters in a year, and they're doing it over 1 year, so our period would be 4, because we're doing it per quarter or 4 times, and per quarter for 1 year, so that's going to be 4. The next thing, at 12% per annum, so 12% again, not seen anywhere up top, so literally it's a good hint that you have to do some more. So if you think about it, that's 12% per annum, but we're compounding quarterly. So that's going to be 12% divided by the 4 quarters is going to be equal to 3%. So there's our percent. There's our intersection value. We can now take our intersection value and multiply by 15,000. So our future value for B, I'm going to just make myself a little bit of room by erasing down at the bottom, just to kind of give me some room to work. So our future value for V, future value equals $15,000 multiplied by 4.184, which we got from our intersection point. And I can just take a second on my calculator. 15,000 times 4.184 to get 62,000. Oops, that's not that 2. $62,760 is our future value. All right, B, done. C, find the payment or contribution per period of an annuity with a future value of at 3% per annum compounded annually for 4 years. So this one gets a little bit different. So number one, what we got to do is we got to repeat what we did at the very start. repeat what we did at the very start. So number one, we take, we look at our information here. So upon the payment, it's compounded annually for 4 years. So it's compounded each year for 4 years. Our period will be 4. Next, we have a percentage of 3.5% per year, and we're compounding annually, so we don't need to do any crazy math. Easy to find our intersection point. Now, note, this gives us our future value. We need to figure out the payment we need to make, so that way we will have this at the end. So it's a little bit different from what we just did. Instead of multiplying to find future value, we have future value, we have our amount, we just need to figure out what our contribution is going to be on a regular period of time. So let me just erase a little bit to make a bit of room for myself, because I've written all over things. So we know that our future value is going to be, or that we want it to be, 76,713. It's going to equal our intersectional value of 4.215 multiplied by some number that we do not know. So that means we're going to divide by 4.215 and divide by 4.215, which means our contribution amount is going to be 76,000, sorry, 76,000, oh, I'm apologizing if I'm just looking over to get my calculator, divided by 4.215, and our regular contribution amount is going to be 18,200. So that's going to be our regular contribution amount that we're going to make over the 4 years to end up with 76,000 at the end of the day. All right, I need to erase things because I've run out of room. I might do D up above. Let me just erase to clean up a little bit, just to make things a little bit easier. Erase my answer I just got. Hope everybody sees how I got D. Let's just finish off with, sorry, everybody saw how I got C. Let's finish off with D. So, number one, we've got 7% per annum compounded biannually. That means twice a year. So that means we're going to take 7%, divide by 2 to get 3.5%. So that's the first piece of information we can use. I'm just going to clean up our table a bit. So again, we're using 3.5%. And the other thing we need to figure out is, number one, it's being contributed for 1 year per period from annuity of the future value compounded biannually, so twice a year. So if we're doing it for 1 year and it's for twice a year, there's our first value, and we are going to be operating at 3.5%. There's our future value amount for $1. So again, it's going to involve dividing. So we want to have a future value of this over 1 year with 2 contributions. How much must our contributions be to be able to have it be that amount? So we take this amount, divide by 2.035 to get the answer of, let's grab my calculator, 60105 divided by 2.035 equals, and that's an even $3,000 to be contributed over time. So that way, at the end of it, with interest, it'll be valued at $6,105. All right, I hope this helps you out. Take care.